Greetings! In this video we will discuss the CLI for KubeRocketCI. We will get familiar with what the KRCI tool is, why you need it even if you already have the portal, how to install and log in, and how it becomes a tool an AI agent can call on your behalf. The KubeRocketCI portal gives you a fast, detailed view into your CICD process and manages microservices development. A lot of day-to-day platform work happens in a conversation. Something is failing, something is drifting, something is vulnerable. Repeated checks might get you bored and drain your energy, so you start wishing these things were automated somehow. Let's get it running. Installing KRCI is a couple of commands. We already have the tool installed, but we will repeat the commands for you. Once the tool is installed, the login procedure reuses your platform's OEDC provider, no separate set of credentials to create or manage. So what does KRCI actually expose? A short tour of the top-level surface. Auth handles login and session status. You authenticate once and every other command reuses it. Note that the KRCI tool needs to access the OEDC provider in your platform. In our case, this is Keycloak. The CLI tool for KubeRocketCI calls for a specific client for your OEDC provider. To learn how to create one in Keycloak, we recommend reading our documentation. Navigate to the portal, Guides, Operator Guide, Authentication and Authorization, KubeRocketCI CLI Keycloak Client. This page walks you through the whole setup, creating the public KRCI CLI client, configuring redirect URIs, assigning the right scopes, and adding the Kubernetes audience mapper so the same token also works against your cluster's API server. One more thing worth knowing is that it's scoped to the platform's default namespace only so far. Then there's the delivery group, projects, deployments, environments, and pipeline runs. The quality and security group covers SCA for dependency and vulnerability findings, and Sonar for code quality gates and issues. And version simply prints the CLI's own version. Every one of those command groups follows the same shape, and that predictability is the actual point. Most groups give you list and get, sometimes the third verb, such as start for pipeline run, which triggers a Tekton pipeline run by name. And every data-producing command supports the JSON output alongside the default table. The same output is exactly what an agent or a script parses. That's the first reason to reach for KRCI instead of the browser. KubeRocketCI is built in a way its primitives are reachable from every runtime that matters, not just the portal's browser tab. For automation purposes, you can build scripts around the KRCI tool to continuously monitor platform state, like this one, which runs daily, checks for new vulnerabilities across your operators, and writes the result into a file with a fixed format. The same command, wrapped in a short bash script, becomes a cron job or a Kubernetes job, a daily report, and it can forward straight to Teams or Slack. And this works without any agent at all. The portal shows one resource type per screen, but the CLI's JSON output lets you cross-reference two lists at once. Diffing project list against SCA list surfaces every codebase that hasn't produced an SBOM yet, something you can't see in a single portal view. But there's yet another runtime where the command line tool gets genuinely interesting. Give an AI assistant shell access and it can run KRCI commands on its own, just like a person would. List codebases, inspect SBOMs, compare branches, summarize what changed since the last run. The agent composes the invocation, and the tool does the work. There's no MCP server to write and no proprietary protocol to learn for this to work. Everything required is already composed in the CLI tool. The agent just reads terminal output the same way it reads any other command's output. No stale API client to maintain on either side. The only detail the agent has is the context related to the tool. So, having both agent and command line tool allows us to interact with the platform via LLM, such as Claude Code or any other. This, in turn, allows us to apply AI to conduct troubleshooting or resource analysis. Let's call the agent and ask it to do several tasks. List every codebase whose SBOM hasn't been generated yet. Then check if any of the codebases that do have an SBOM report critical vulnerabilities. As you can see, it composed the invocation itself using the KRCI tool, no bespoke API client. We got a detailed report with a table that contains all the codebases with missing SBOMs. Give me the SCA report for the EDP codebase operator. Again, no over-engineering, just KRCI commands, read and combined by the agent. This was the overview of the KRCI tool for the local terminals. It allows for automating a routine using bash scripts. Additionally, it serves as a layer of interaction between a platform and user, be it a developer or an agent. It is quickly installed, but it requires access to your OEDC provider. We covered why it exists alongside the portal, how the same command runs across pipelines, schedulers, and AI agents, what the top-level surface looks like, and we installed and logged in for real. That's it for today. Thank you for watching and have a great day.